A warm welcome, dear students. Today we will start with real numbers, exercise 1.2 for sum. Prove that root 5 is irrational. Now, to prove root 5 is irrational, we have to do a contradiction method. That is, we have to assume that root 5 is rational. Then, with our proof, prove that it is irrational. Okay, so first to assume, we will take, let root 5 be a rational number. Now a rational number, I told you in the concept, rational number is in the form a by b, where a comma b are co-prime and b not equal to 0. This note is very important. If you don't write this note, you will not get any marks for this answer at all. So this is very important. A and b are co-prime and b not equal to 0. B not equal to 0, when b becomes 0, what will happen? When b becomes 0, when a denominator, normally in any fraction if b becomes 0, that is the denominator. B means the denominator becomes 0, it is undefined. This should not happen, students. So we should always be careful that our fraction denominator should not be equal to 0. Okay, now let me tell you what is co-prime. Co-prime means the numerator and the denominator, the a by b, the numerator and the denominator should have common factor as only 1. Common factor should be only 1. Only 1. No other common factor you should have. It need not be prime numbers. So first point is common factor is 1. And it need not prime. Both numbers need not be prime. Need not be prime. Both number, I'll just give you some examples. Like 4 and 9. One number even number, one number other number. Both are not prime numbers, so non-prime numbers. Or it can be both prime numbers. Or it can be consecutive numbers. Consecutive numbers are always prime, co-prime. Okay, so 6 and 7. So here if you see, the factors of these numbers are only 1. They don't have any other common factor. So they should not have any other common factor other than 1. This is the criteria for co-prime. Okay, so then we proceed with the sum. I just wanted to tell you this. Yes. Now, since we have taken it to be a rational number of the form A, so we have root 5. Root 5 is equal to A by B. So now we are taking A is equal to, we'll just transpose root 5B. Now squaring on both sides. It is A squared is equal to root 5B the whole squared. That is A squared is equal to 5B squared. Okay, so this will have it as 1. This implies that 5 divides A squared, which implies 5 divides A. By theorem, this one we'll take it as 2. By theorem, 1.2. This you have to write. Okay, this is also important. See, and that part I told you important, this also you should write. Okay, this is from the theorem. Okay, so, and I'll tell you what this is also. So this is, suppose a is equal to 10, b is equal to 5, which is a prime number. Now a squared will be 10 squared, that is 100. 100. Now we can say that 5 divides a squared, which implies 5 divides a. This means that 5 is a factor of a. Okay, now let a is equal to 5c. Now this a, will take it as 5c. Okay, now again squaring, we will get a squared is equal to 25c squared. Okay, this is 3. Now from this, from 1 and 3, 1 and 3, this is also a squared is equal to 5b squared, this is also a squared is equal to 25c squared. So we will equate 1 and 3. Okay, so from 1 and 3, 5b squared is equal to 25c squared, which implies when we divide by 5, b squared is equal to 5c squared. Okay. So from this we can say that 5 divides b squared and 5, therefore 5 divides b. This is 4th point. So from 2 and 4, what is 2? 5 divides a, 5 divides b. Okay, so we can say that 5 divides both a and b, which implies 5 is a common factor of a and b. A and b. So this contradicts our assumption that A and B are co-prime. I told you A and B are co-prime. That means they have only one as their common factor, but here they are telling that there is a 5 that is a common factor for both A and B. So this contradicts our fact that A and B are co-prime. Okay, therefore our assumption is wrong. We can't assume that is wrong. Therefore root 5 is irrational number. Irrational number. Students, this sum is very, very, very important, actually very easy. In the beginning, maybe it will be little, this thing little for you, difficult for you to understand, or like think little heavy, it is big for you. But when you go through, copy the sum, leisurely just go through this, go through all the points I said. After that, you just write and see 2 or 3 times. So it will be very easy. Thing is, for if you get this sum in your exam, you will be really lucky, because this does not involve any calculations or anything of that sort. So very easy, just a proof. Okay, just if you just write the here the numbers will be different. For sometimes you will get root 5, root 2, root 3, root 7, any prime number you will get. So instead of there, wherever you have this 5 and 5, you have to just substitute that 7. In case you get root 7, you have to substitute in the place of 5, you have to substitute 7. Okay, so like that. And definitely I'll tell you, for this exam, like when you have after your finishing real numbers and polynomials, you'll have a small test. In those tests, definitely you'll get the sum. And so it will be very useful for you to score good marks in this particular test. It is a definite sum. So, and here this real numbers, prime and co-prime, A and B are co-prime, B not equal to 0, definitely you have to write. If you don't write this, if you miss out this, it is this and this also. So that's why I put important. If you miss these two, you will not get marks, especially when you miss out this co-prime, because that is the main aspect of the sum. So you have to write co-prime, and all the other sums in this pattern, same proof you have to write. That is, I'll tell you, in other sums also you will have addition and other things, but this same proof will repeat in the other sums also. So if you learn one sum, this proof, you can attempt any of the sums of that sort. Okay, we'll move to the next sum. Second sum, 3 plus 2 root 5. This is what I said. Here you have 3 plus 2 root 5. Here also the same proof for root 5 you have to write. I'll tell you how to write. I'll just write the sum. Okay, so this is very easy. Once you learn that format, that sum, you learn properly, then you can attempt. These sums are all very easy for you. Now let solution 3 plus 2 root 5 is a rational number. Rational number, that is 3 plus 2 root 5 is equal to a by b, where, so this is very important, where a and b are, a comma b are co-prime, and b not equal to 0. This is very, very important. You have to write this. Okay, so next step, we will transpose this. We have to take only this root 5 to your left hand side, bring others everything to your right hand side. So this is the pattern. So root 5, so if you I'll take 3 to the right, so it will be 2 root 5 is equal to a by b minus 3. So I will just solve it. I'll take the LCM, a minus 3b by b. Now I will take 2 also to the side. So root 5 is equal to a minus 3b by 2b. Okay, now let root 5 be a rational number. Number root 5 is equal to a by b, again a comma b are co-prime, b not equal to 0. Okay, now a is equal to root 5b, squaring on both sides, squaring on both sides. I'll get a squared root 5b whole squared, that is a squared is equal to 5b squared. Okay, now 5 divides a squared, which implies 5 divides a by theorem 1.2. Okay, now this is 1, this is 2. Now let a is equal to 5c. It's another integer. A is equal to 5c. Again squaring, you will get a squared is equal to 25c squared. This is the third one. From 1 and 3, I'll just equate the right hand side. Okay, 5b squared is equal to 25c squared. So it is very easy for you to remember, children. Once just you sit and analyze, you do your practice of once or twice, you will get it. So 25b squared this again here 5 divides is b squared, which implies 5 divides b. Okay, now with this from this is 4, so from 1 and no, from 2 and 4, from 2 and 4, 2 and 4, we can say that 5 divides a and b, a and b, and 5 is a common factor of a and b. Therefore, our assumption is wrong. Then this contradicts our assumption, the fact that a and b are coprime. Our assumption is wrong. It's just a stereotype thing, children. Therefore, root 5 is irrational. Now I'll tell you how to conclude. And one more explanation I wanted to give is, like, I just wanted to give an for there itself I want to explain this just for explanation. Suppose a is equal to 10. I just want to explain this concept. A is equal to 10 and b is equal to 5, which is a prime number. Now a squared is equal to, I don't know whether I told there, that's for some, then this is equal to 100. Now 5 divides a squared, so this means that 5 divides 100, which implies 5 divides a, that is 5 divides 10. Okay, so this is the explanation I want to give you. Okay, so first, after finishing this, so if you have a sum like this, you have to prove whatever number they give. They can give any number, suppose 5, 7, 3, whatever, root 5, anything they give, you just have to do the same thing and then do the same thing and then write the conclusion with that sum. Now LHS, that is root 5 is a irrational number. RHS is what? There we had no a by a minus 3b by 2b is a rational number. Which is wrong, our assumption is wrong. Is wrong. Therefore, 3 plus 2 root 5 is irrational number. Okay, children. So you have to, for any sum, you have to write the whole thing, this part, and then conclude. You cannot write just the interaction part and just leave it like that. You have to prove that this root 5 or root 2 or root 7 is irrational and then move to this conclusion. Then only you will get marks. It may be any marks, 3 marks, 4 marks, anything. But I'll tell you now, prove the following numbers are irrational. First number is 1 by root 2. Okay. So 1 by root 2, same way. 1 by root 2 is equal to, let 1 by root 2 is a rational number. Number 1 by root 2 is equal to a by b, where a comma b are co-prime and b not equal to 0. Okay, so it is 2a is equal to 2a is equal to b. Pairing on both sides. So root 2a whole squared is equal to b squared. So 2a is equal to 2a squared is equal to b squared. Okay, so you can write b squared is equal to 2a squared. Okay, now 2 divides b squared, which implies 2 divides b by theorem 1.2. So this is 1, this is 2. Now let b is equal to c, b squared is equal to 4c squared. Okay, from 1 and 3, 2a squared is equal to 4c squared. So a squared is equal to 2c squared. So 2 divides a squared and 2 divides a. Okay, this is 4. Now from, I think if you see this video itself, you will learn this. All the sums, if you just see, you will learn this. So from 2 and 4. 2 and 4, we can say that 2 divides a and b, which implies 2 is a common factor of a and b. This contradicts common factors as a and b are co-prime. Our assumption is wrong. Root 2 is irrational number. After writing this, you go to the sum, that is second part. Now let 7 root 5 be a rational number. So 7 root 5 is equal to a by b, where a and b are co-prime, b not equal to 0. Okay, now I will take root 5 alone on this side. I will bring 7 on the other side. So it is a by 7b. Okay, now let us assume, let root 5 be rational number. So root 5 is equal to a by b, where a and b are co-prime, b not equal to 0. So root 5 b is equal to a. So squaring on both sides. So a squared is equal to, I'll take it to the other side, a squared is equal to 5b squared. So this will be 1, 5 divides a squared, which implies 5 divides a. This is 2. Now a is equal to 5c. So squaring will get a squared is equal to 25c squared. This is third one. From 1 and 3, did I write theorem? Yeah, by theorem 1.2. This is very important. So from 1 and 3, 5b squared is equal to 25c squared. So b squared is equal to, if we divide by 5, you'll get 25 5c squared. So 5 divides b squared, which implies 5 divides b. This is 4. So from 2 and 4, 5 divides a and b. Therefore 5 is a common factor of a and b, which contradicts the fact that a and b are co-prime. So our assumption is wrong. Therefore 7 root 5 is irrational. Let 6 plus root 2 be a rational number. Number 6 plus root 2 is equal to a by b, where a comma b are co-prime and b not equal to 0. Okay, now you have root 2 alone on the right and left hand side. Root 2 is equal to a by b minus 6. We'll take the LCM. A minus 6b by 6. Sorry, 6b by b. Now we have to prove that root 2 is irrational. Okay, so let root 2 be a, this is because this is a by b form. Okay, so we are assuming, since this right hand side is in the form of RHS in form of a by b, we assume root 2 is rational. Okay, so right hand side is rational, so left hand side also we have taken it as rational. Okay, so root 2 be rational. So root 2 is equal to a by b, where a comma b are co-prime B not equal to 0. Okay. Now A is equal to root 2B, squaring on both sides. So A squared is equal to 2B squared. So 2 divides A squared, which implies 2 divides A. This is 1. This is 1. This is 2. By theorem 1.2. Okay. Now let A is equal to 2C. So A squared is equal to 4C squared. So this is 3. From 2 and 3, no, 1 and 3, 1 and 3, 1 and 3, 2B squared is equal to 4C squared. So B squared is equal to 2C squared. So B squared, 2 divides B squared, which implies 2 divides B. This is the fourth one. So from 1 and 4, 2 and 4. From 2 and 4, 2 divides A and B, which implies 2 is a common factor of A and B. This contradicts our assumption that A and B are coprime. So apart from 1, there is another factor 2. Okay, so our assumption is wrong. Therefore, root 2 is irrational. So LHS is equal to irrational, that is root 2. That is root 2. Okay. RHS is equal to rational number. This contradicts our assumption therefore 6 plus root 2 is irrational. That's all, students. Now, apart from, see, your textbook, NCERT book is just a glance only. Okay, but for the exam you will get more sums in your other patterns, in same pattern but different numbers and other extra sums we have to do. So after finishing each chapter, I will do little revisions from the extra work, like worksheets. We will discuss and do worksheets from other books and other PYQs also. So that only is going to be important. This is just for the concept and just few examples. But apart from textbook, we have to do lot of worksheets, lot of sums for practice. Okay, that I will be doing in the separate video.